In one part of the world, rabbits are treated as an environmental disaster. In another, they are quietly changing the fate of an entire landscape. While Australia spends billions trying to control an exploding rabbit population, China deliberately brought millions of the same animals into one of its most hostile deserts. What followed transformed sand into farmland, poverty into income, and a place once called the Sea of Death into something entirely different. How did a small animal become the center of one of the most unexpected ecological, one of the most destructive environmental processes on Earth? It begins quietly, often unnoticed, then accelerates until land loses its ability to support life. Moisture disappears, vegetation collapses, and soil turns into drifting sand. In northern China, this process threatened entire regions for decades, placing pressure on food security, infrastructure, and human settlement. Among the hardest hit areas was the Kubuchi Desert, a vast expanse covering more than 18,000 square kilometers along the Yellow River Basin. For years, Kubuchi expanded at an alarming pace, swallowing hundreds of thousands of acres annually. Productive farmland was buried under sand. Villages were abandoned as water sources dried up. Seasonal winds lifted fine particles into the air, carrying sandstorms toward nearby cities and damaging roads, crops, and public health. What had once been marginal land turned into a moving environmental threat with regional consequences. The Chinese government recognized the danger early. Beginning in the mid-20th century, large-scale intervention became a national priority. Sand control stations were constructed to slow wind movement. Barriers were placed to trap drifting dunes. Large tree planting campaigns followed, supported by state funding and scientific research. Millions of saplings were planted year after year in an attempt to anchor the soil, yet results remained fragile. Strong winds erased years of work in a single season. Survival rates of planted trees were low. Maintenance costs rose steadily, while the desert continued its advance. Each solution treated a symptom rather than the underlying instability of the land itself. To most observers, Kubuchi appeared unwinnable, a landscape locked into irreversible decline. But for one local entrepreneur, the failure of conventional methods revealed a deeper flaw in approach. Instead of forcing control through engineering alone, he began to question whether the desert could be guided rather than resisted. What if stability did not come from overpowering nature, but from redesigning how life interacted with it? Wang Wanbiao approached the problem with an idea that, at first glance, appeared impractical. Instead of relying solely on large-scale engineering or chemical interventions, he focused on rebuilding the desert's biological structure. His approach began at the surface level. On open sand, his team arranged dry bushes into carefully measured square grids. These grids disrupted wind flow close to the ground, reducing the speed at which sand traveled. As sand accumulated within the squares, moisture that would normally evaporate was retained for longer periods, creating small but critical pockets of stability. Inside these protected zones, willow trees were planted. The choice of willow was deliberate. This species had already demonstrated an unusual ability to survive in harsh, water-scarce environments. Unlike shallow-rooted plants that quickly perish in desert conditions, willow trees send their roots deep underground, sometimes hundreds of feet below the surface, reaching water sources inaccessible to most vegetation. Once established, these roots acted like underground anchors, binding loose sand into a more stable structure. As seasons passed, the impact became visible. Sand dunes that once shifted freely began to hold their shape. Wind erosion weakened. Moisture levels increased slightly but consistently. For the first time, vegetation survived long enough to influence the environment around it. Progress no longer disappeared with the next strong wind. The desert's expansion slowed, not because it was blocked, but because its internal dynamics were changing. After several years of success, the project encountered a new obstacle. For willow trees to become economically viable, their growth needed active management. The value of willow wood lies in the thickness and strength of its main trunk, qualities that require regular removal of new shoots. Without pruning, the trees would grow thin branches rather than strong stems. Carrying out this work manually across vast desert areas proved slow, expensive, and unsustainable. Labor costs threatened to outweigh any environmental gains, placing the entire project at risk. The solution emerged from biological behavior rather than mechanical innovation. Wang introduced Rex rabbits into the system, a breed valued for its dense, soft fur. These rabbits possessed a feeding habit that aligned precisely with the project's needs. They preferred young, tender shoots and naturally avoided thicker stems. As they fed on the new growth of willow trees, they performed continuous pruning without human involvement. This interaction reshaped the project's economics. The rabbits maintained the trees while sustaining themselves. The trees, in turn, produced high-quality wood, suitable for paper and furniture industries. At the same time, rabbit fur entered luxury markets. Environmental restoration and commercial productivity became part of the same process, rather than competing priorities. As willow coverage expanded, changes beneath the surface became even more important. Root networks penetrated deeper and wider, compressing loose sand and improving its structure. Wind struggled to displace the surface. Moisture remained trapped longer after rainfall. Temperature fluctuations near the ground became less extreme. The desert began transitioning from a moving system into a more stable landscape. Rabbits accelerated this transformation in unexpected ways. Their waste enriched the soil, introducing organic matter where none had existed. In China's zero-waste agricultural framework, this byproduct was collected and reused, but much of it remained where it fell, fertilizing the ground naturally. Soil fertility increased rapidly, allowing grasses and other plants to take hold. Reproduction further amplified the effect. Rex rabbits reproduce at a high rate, with a single female capable of producing dozens of offspring annually. As populations expanded, so did the volume of organic material return to the soil. Biological activity increased. Microorganisms returned. Formerly sterile sand began supporting plant life within a few growing cycles. Another crucial factor lay in the rabbits' digestion. While they consumed grass efficiently, grass seeds passed through their system undamaged. These seeds were deposited back into the soil encased in nutrient-rich waste. Grass spread without deliberate planting, reinforcing soil stability and creating continuous vegetation cover. What began as a solution to a maintenance problem evolved into a self-sustaining ecosystem. Willow trees stabilized sand, rabbits regulated growth and fertilized soil, grass restored ground cover. Each component reinforced the others, reducing the need for constant human intervention. With proof established, the project expanded. Heavy machinery reshaped dunes into manageable terrain. Willow planting increased. Local residents were trained and supported to raise rabbits themselves. Millions were imported and distributed. Entire communities became participants in a new ecological economy. Over time, Kubuchi transformed completely. International assessments showed that roughly 1/3 of the desert transitioned into stabilized green land. This outcome was not the result of a single breakthrough, but decades of aligned biological, economic, and environmental strategy. The environmental shift in Kubuchi was matched by a profound economic transformation. What had once been a region associated with loss and migration became a center of long-term investment. The Chinese government directed billions of yuan into infrastructure, housing, and employment programs designed to support the new ecological system. Roads, water networks, and settlements were built to serve a population that no longer needed to flee the desert. Thousands of farms emerged, each linked to rabbit breeding, forestry, or agriculture. Every year, millions of Rex rabbits entered regulated commercial circulation, supporting textile and agricultural markets. Average household incomes rose steadily in communities that had once been considered uninhabitable. Kubuchi's success soon attracted global attention. A landscape long known as the Sea of Death began to be referenced as an ecological model rather than a warning. As stability increased, renewable energy was integrated into the system. A massive solar power installation spread across thousands of acres, generating billions of kilowatt hours of electricity. Beyond energy production, the solar panels altered the desert environment itself. By blocking direct sunlight, they reduced surface evaporation, Wind speeds dropped as airflow patterns changed. Shaded ground beneath the panels retained moisture, allowing grass to grow where bare sand once dominated. Rabbits grazed in these areas, controlling vegetation and continuing the cycle of fertilization. The contrast with Australia became a central lesson. There, rabbits multiplied without effective control, damaging native ecosystems and agriculture. In Kubuchi, the same species was managed within strict limits and integrated into a broader system. The outcome was not destruction, but stability. Today, Kubuchi supports agriculture, renewable energy, wildlife, and permanent human settlement in balance. Sheep graze beneath solar panels, willows anchor dunes. Rabbits move through the landscape, maintaining the system they helped create. As desertification threatens nearly half the world's land, Kubuchi is studied as more than a regional success. It represents a shift in thinking, one where cooperation with natural systems replaces constant struggle. If a desert can be reshaped through understanding rather than force, the question that remains is simple. How many other landscapes are waiting for the right idea to bring them back to life?